The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dan DuPont of HawaiiTracker.com, bringing you guys another Kīlauea volcano update. We're titling it here Hawaiian Volcano Tracker, just as a trial here. Today is Thursday, May 12th, 2022, and we have pretty typical activity on Kilauea. It seems to have settled into a fairly consistent pattern. Not a lot of overflows, the lava lake's been visible, ooze upflow is still around the perimeter, so we'll recap all of that here today for you guys. Answer some questions, we'll talk some earthquakes. This week's Volcano Watch is on a Pāhala earthquakes. You guys keep asking about that. Today's a week we'll talk about that a little bit more, along with other deep Kilauea earthquakes. And finally at the end we'll touch back on 2018 a little bit as far as looking at the caldera collapse part of the sequence here. So we'll get into it right away, and let's get something to add, Dane, here at the start?
No, go right into it, I think.
All right, so let me get us going here. So what you guys are seeing here to start our weekly summary is that zoom in on that main persistent lava lake at the summit of Kilauea. And you can see it's the whole last week here sped up from the V1 camera. So we're looking from the west. North would be kind of that way, like that. Maybe north. Lava's been moving from this western corner, and it goes over here to the southeast, and it goes to the northeast and to the east as well. And it seems like it's got three spots here, here, and here, where it recirculates back underneath the crust of the crater floor here. So the whole thing has got lava underneath it, but it's formed this thick crust, and that whole crust is being buoyed, lifted upwards, as has been the case for the last many months now. So as far as what you can see, this is typically what the visitors to Hawaiʻi Volcanoes National Park are looking at, from a different angle, of course. But it goes to show that there has been consistent activity all week, and not a whole lot of really anything unique to note there. So we'll move on to the wider view, which is the KW camera here. We had just been zoomed in just into the persistent lava lake area right in there. But as you guys can see, there is a much larger area of lava that's covering the crater floor, and I'll outline it here. It's all of this. And this all goes all the way back to here. And it's kind of got those two ears that point here to the northeast, this one, and the northwest down over here. Right? And so you can see all these little glowing spots when we have the camera flipped to nighttime are these ooze-up flows around the perimeter that occur. This is over here in the east. It looks like this long channel. They look kind of skinny because it's so far away. The closer ones over here, you can see they activate at some point during the week and flash behind this big red rock. It's sticking up. And there are other ooze-up flows over here. There are ooze-up flows back over here. So they're kind of happening more or less all around the perimeter of that crater floor there. And we'll come back to this camera a little bit later, but we'll move on for now and show you that same view in the thermal imagery here. So there is that persistent lake right there. You can see some of these ooze-up flows as these not quite as bright, but you can see, unless it's close, this one over here is fairly bright here as it oozes up close to the camera. The farther one's not always as much, but it's a similar process is happening all around the perimeter. And maybe you can tell from the coloration, depending on the quality of your video there, but there's a little bit darker color blue right in here, and that's what marks that old crust from when eruption began, from the previous filling of a lava lake. And that crust seems to be more buoyant than everything else around it, right? So that's the cap that keeps rising upwards, and then as it does, around the edges is where lava leaks up. And it's filling in this kind of a moat area all the way around it there. And one of the edges, right over here, is this west vent complex. And the lava has been coming up through this area for a while, and we have seen various forms of lava entering the active lava lake over time right there. All of that's been crusted over, and in fact we haven't seen a whole lot of activity in this west vent complex in a few weeks now. Small little overflows and glowing, but really nothing major, and maybe that in itself is notable that it's really been a while since we've seen this much stability in this area, which perhaps just goes to say that everything is still working well with the crust buoyed upwards and enough space for all these ooze-ups to continue around the outside, and really there's not enough pressure to burst it out of here when it can ooze up everywhere else it wants to. Fairly easily, it seems. Alright, let's move on from the thermal camera and, well, show you the most current view. That was a time-lapse for the last week. Here's a most recent view from just before 5 p.m. And likewise, persistent active lava lake, ooze-ups along that eastern boundary, and some glowing from this west vent complex area. And this thermal camera is looking through the fume, so it's not as easy to see all of that. We'll look at that here shortly. But big picture first of all, and I'll play for you guys here. This is the whole eruption back from September, so it's speeding through quite quickly. But what you can see is that rising of the crater floor and ooze-ups around that perimeter that kind of keep flashing almost like a little disco ball. And there are times when that inner part gets flooded with lava as well, but for the most part it's flows around a perimeter. That's is the evidence of this lifting up and oozing out. I'll just do it one more time here real fast. Maybe not quite that fast, but just so you can see this clear lifting process that's been going on here. So it's really been quite a lot of lava. The rate's been pretty steady as far as we can tell. We know there was an overflight that occurred this past week, and so we'll await results from the USGS as far as new volumes and metrics that we can then calculate some rates from. Okay, so while we're at a big picture, this is from the S1 camera. Dane put this together using the S1 camera daytime views only. And this is going back as well, a couple months. So you can see a little bit of this lifting process. There's a little shift in the camera that occurs later on here. But you can also note this fairly consistent presence of the circulating lava lake. You can see that the lava levels rise and fall a little bit. Maybe if I can zoom in a little more, you'll see easier. Lava levels rise and fall within the pit, and that's what corresponds to the deflation inflation. That happened a little bit earlier in the week, although hard to tell as easily just from the depth graph. We'll talk about that shortly. But otherwise, the interesting feature here is this southeast pit that the lava channels through in this rapids cascade, and sometimes it's all the way full and matching. And when lava level goes down, it seems like that's when it really starts looking more interesting, and we have that lava falls and drainage through there and all of that. So those are the long-term changes. And now we will look at the monitoring. And let me find my... Oh, here we go. My transition here. Let's put the right subtitle on there. And now we're looking at monitoring data. So Kilauea monitoring data long term, this is a GPS summit line, and this is the cross caldera distance. So it's a distance from north to south across the caldera. And you can see prior to the eruption, which began right in here, the caldera was extending, the sides were getting farther and farther apart, so this line is going upwards. And then it started going downwards very quickly as the eruption began and relieved that pressure initially. And it was fairly stable for a couple months, and really for the last at least 6 months or so, it's been rising a little bit slowly and then maybe slightly more quickly here in the last couple months. But still very slowly doing that, not nearly as fast as it was before. And it's just going to show that overall, even though we're erupting lava and lava is filling the crater, we're still building lava underground and pressurizing the summit area to still be able to spread. Right? So it's still spreading very slowly. It's not getting pushed nearly as fast. The whole thing is constructed that it does move, right? And all these blocks do move, and so it's kind of evolved to be that way, right? There's nothing alarming about it moving and about it spreading and all of that. It's just a noteworthy thing that, the whole thing isn't a net loss, and this essentially leads me to believe that high rate we had coming in for the last 15 years now of lava, coming in that led to the 2008 activity at the summit, 2018, all of that. The lava is still coming in. That lower source really doesn't appear to have changed as far as I can tell. And the consequences are just how the top is reconstructing itself. And so there's plenty of room up here to fill the caldera, fill the collapse area with the lava that's coming in, and that's what we're seeing here. And this next plot down is showing the East Rift Zone, and the East Rift Zone is actually getting closer together, which shows that lava is not building up there. Doesn't mean the lava isn't going in there. That's what the Rift Zone actually does, is it accommodates lava moving through that deeper area there, as one component of it. It's currently not showing signs of any excess pressure or anything like that, right? It's actually been contracting, sagging closer together since eruption began, right? So all the buildups all underneath the summit area, if there is any slight buildup beyond keeping the eruption going. So that's the GPS lines as far as the depth of lava here from the beginning, late September until now. It's been an upward trajectory. And we're now at about 350 meters on this plot here. That puts us at about 110 meters, I think is more or less what we've gained. I would estimate for this whole eruption now. And although it appears to be a little bit more from this graph right in here, we'll have to look at the discrepancy in the future. But new data coming out, we hope next week. We'll come back to this. If you haven't seen this graph before, this little wiggles in here is because we're pointing at the lava surface itself that was going up and down with inflations, and then before and after we appear to be pointing at some other part of that lava crust, which is still rising, but it's not fluctuating in that short term going down as much in particular, right? If we zoom into it as far as the last week, here is the depth in the top panel for the last week. And it's instructive to look at this bottom panel as the last week of the summit tilt as well. So the scale isn't huge. We're looking at 3 microradians to -3, so it's about 5 microradians top to bottom. We had a deflation-inflation event that occurred here a few days ago, lasting about a day or so, right there. And you can see that when that pressure dropped, that's when the lava level really wasn't rising. It was essentially flatlined right through there. And as we've had inflation since the end of that deflationary event, we've correspondingly had an increase in lava level as well. Right, there are other times where it's more stable, where we're also seeing stable. But overall, you see without the drops, a very similar pattern on the depth as you see on the pressure proxy of ground tilt here. Looking at the last month, I'll change our timescales here a couple of times just to give you guys all different views of this. So for the last month here, we are in that last little upswing. There was that flat part. You can see we had previous upswings, flat, so you can see the stair-stepping pattern that we started describing last week. And so in this case, seemingly tied to, if you look at the tilt on the lower panel below here, these flat parts occurring when we have these big deflation-inflation events. Right? So same there, not a whole lot of difference. The tilt has also been tied to the SO2 emissions, and so that's what we're looking at in this bottom panel here is the last month SO2. There have been variations as well from high points to low points during those deflation-inflation events. And the last 2 points we have here, really just one in the last week, has been similar to the previous week. So it's normal in the range, nothing surprising or alarming there. And that's going to transition us here to talking about our volcanic hazard summary, because our hazards do come from the gas. Gas is our main hazard here. We can look at the Manoa VMAP, VOG mapping project, and look at the forecast for the VOG given the emissions of about 2,700 tons per day and current weather patterns, and we can see a pretty heavy impact on the west side of the island here. These are all just moderate thresholds, so this is not anything potentially hazardous, right? But something to be aware of, and people who are from the area know what they're looking at, and if you're possibly sensitive, then just take your precautions as usual. Nothing alarming. This has kind of been standard for a while now, but worth noting that we're living with it, especially if you're over here in this southwest part of the island, especially. Within the park itself, which we'll talk about here shortly as far as viewing, everything is in the green. VOG blows to the southwest for the most part. There can be, especially during slack winds, it can kind of build in this lower area right through here. So we have heard reports of people smelling VOG in the area, but it's not reaching any of these hazardous levels. It's still staying in the green here in the park. All right, so we will switch from our hazards to lava viewing. And looking at the park map here, Kilauea caldera, there is where a lava lake is sitting. It's about in there right now, something like that. We've discussed before the various overlooks. Kanakakoi we'll talk about second today. We've mentioned Kupinaʻi over here, Waldron's Ledge in the east, Volcano House area that we still have to show you some more footage of at some point, but there are views of some parts of this back part of the lava lake from there as well. And finally, we've also been discussing this Uekahuna Kilauea overlook area from the north, which also can see kind of this northeast quadrant of the lava lake area there. So let's look at that a little bit more closely. We have a picture from the USGS this week of that Uekahuna area. So this is the former Jagger Museum and HVO buildings right here. The parking lot remains open while the buildings themselves were damaged by the 2018 collapse we'll discuss later today, and everything remains closed and fenced off, so you can park in a parking lot, you can use the restrooms, and then you can essentially walk two ways. There is an overlook off in this direction, which gets you close to the highest point on the rim that you can be here on Kilauea. and you can look down, but that's not the best spot to look at for the lava itself. For that, people are more going to this overlook right over here. So maybe I can zoom this in, but before I do, I'll point out beyond Jagger Museum parking lot over here, Wikahuna parking lot, there's also the Kilauea Overlook parking lot is over here. And so you can see these are the two turnoffs. And either way, it's not exactly halfway. It's a little bit closer to Wikahuna. Let's zoom into that right there. And see, it's actually a paved trail coming in from both sides. And then there's a little dirt area right here. And there's an old survey platform right in here that people kind of gather around. And there's better viewing, more or less in this corner, but it kind of depends where you are, what you can see over there, right? So you can see there's a trail from Kilauea Overlook over there. Or if I pan it off in this direction, and then try to the parking lot right there. Right, so that's the northern area. And we'll come back to this KW camera. And we'll zoom it way in because it's mostly in here is the area you can see from Wikahuna in the north. So I'll play this for the last week. What you can see is that there is activity happening. You see this, it's not the same as a lava lake circulating, but you can see there's been quite a bit of lava flow in this area over the last week. It's more evident overnight, of course, but if it's happening every single night, then it's also moving in the daytime. So all through there, you can see most people in the last week would have had something to look at day or night from that northern area right there. So pretty cool to see that there's a little bit different things to see, right? And obviously, you can get the best view of that from there, and you can't see this nearly as well from anywhere else. So kind of if you want to see it all, you better plan some time to get all the way around the caldera, because here is the view of the main lava lake area from the south, Kanakakoi. So here's Kanakakoi crater right over here. That previous Kanakakoi overlook is over here, which is still there to look at the fissure zone. But the new trail and overlook right in here. Right. Parking lot is a devastation trail over here, so a bit of a longer walk. But it is on a road for the most part before you come off trail right over here. And we've used the S1 camera as a proxy for a long time. So here's the last week from the S1 camera, showing views of that main lava lake. And once in a while you see the ooze-ups around the perimeter here, or there's a big one that occurs early on back up in here. Sometimes you see them over here at the edge of the camera up in here as well. From the viewpoint, you can see more than just this. You can see further over to the side over here. You can see further over to the side over here. It's slightly a different angle. It's just hard to really compare. But I like looking at this for a view of what the main lake might look like, right? So at some points you might have seen some of these rapids coming through with the lava level dropping, but persistent the entire week, and lots of fume coming out there visible as well. Okay, so we'll turn now to the view from the west. This is the B1 camera. That previous view was looking more that direction here. We're now, north is over here on this side. So active lava lakes over here, the ooze-ups back over here, all the way around. And so let's look at the B1 camera just for completeness to see a different view of these ooze-ups, especially the ones that occur here in the foreground are the ones that I like to see because they're well framed in this camera view. But I think that happens once here at the end. There it is, a big flow at the end there. So, interesting to note, still fume coming out of these cones. These cones are pretty big here on crater floor. We'll have to ask for a measurement, perhaps, at some point. But moving on, we will turn to our friends Two Pineapples on YouTube and a little excerpt of their live stream. So check those guys out on YouTube, Two Pineapples. They've been live streaming many mornings from the public overlook. So I've put together some quick little clips here, a little time lapse of the wider view, zooming in there. You see that main active lake, a lot of fume. Hard to see the crust moving as much, right? Second to second, minute to minute. This is actually even sped up a little bit. But in the nighttime, you see the lava glowing through the crust, as you can see here. Right? Some glow from the upper west vent, but really not a whole lot of action back in there. Sped up, you can see spatter lines against the edge of the lake here. This one's actually moving, migrating along here. It's pretty cool to see that. Back to that other side of the pit, right? Lava streaming in there. There are times when it starts bubbling, and you see all this kind of spatter, and the spatter builds up these ramparts, like these piles of molten lava, of hardened lava on the rim there. Giving it the profile there, so you can see a lot of this spattering activity. This is where the lava is circulating back beneath the crust of the lake, but the gas doesn't want to go down. It kind of comes back up and cause all these bursts and just throws the lava everywhere when it's doing so. So pretty amazing, spectacular stuff. These guys are pretty far zoomed in, so if you're going on your own, make sure you bring some kind of binoculars or telescope or something like that. Once again, mahalo, guys. 2 pineapples. Check them out on YouTube. I believe it's been every week for a while now. They've been streaming from the volcano, so we'll check them out. Okay, we'll turn now to our... we are now going to talk about our media of the week, right? USGS Media. And we're going to start it off with this video from the USGS, taken 2 days ago on Tuesday when the overflight over the volcano occurred. This video is shown at 2x speed. I'm not going to speed it up any further because it makes it a little too jerky there, but you can see coming over that main edge of the caldera wall, coming into view is the edge of the down drop block with all these cracks leading up to the edge of it right there, right? And these are cracks you can kind of see as we fly over. You'll see that they're really little cliffs. You can see with the changing of the light there. And then that main down drop area right there. Right there's our down drop block. The lava lake filling all the dark area. That's all that fresh lava with liquid underneath all of it. Right, and that central part, that buoyant middle part, and that little brown is the island right in there. So this is our high pass across. The camera's going to swing around. We're going to look at Maunaloa here and over the Kau Desert, and then we'll come in for a low pass as well. Lower west, there's the ocean.
Good day for them to get out there. I mean, how much rain has been dropping recently.
Yeah, it's finally got cleared in the last few days, and they took advantage of it, and perhaps that's why we haven't had any overflights for a while. It's been hard to even, I've been trying to meet 2 pineapples for a while, but man, it's hard when a gear gets all wet and all of that, so it's been really rainy for a while, and yeah, great day for sure.
It also tries to make the time lapses pretty seizure-inducing if you don't, curate them a little bit. So
right.
The gas flying in front of the camera and all the steam.
So yeah,
the thermal.
Down at the bottom here, this is that 1982 Fisher line right through there. We're going to look at that again here, but it's pretty cool that a lot of those areas in a down drop block are things we couldn't see before. We can't see very closely, I should say. We can see them. It's just we can't see them anymore as closely as we could before. The collapse when we used to be able to walk out to some of those features, right? I mean, pre-2008, I should say. All right, coming in on a low pass, we're actually hovering right over that down drop block area now, and you get a view of what it might be like to be close to ground level on the edge of that block there. Still see some fume. See the fume coming out along the cracks. So you see this discoloration along the cracks with some of that gypsum, sulfur minerals right through there. Sometimes you see some reddish rocks, right? Right there, there's a fissure flying over that 82 fissure. It's the April 82. And yeah, various other age lava flows there, right? The lighter colored ones being the older ones. And looking into the lake the entire time there, right? There was... Where am I here? So I'm going to rewind this a little bit because... Where's that fissure? There's a spot in here. Right. Further back. What I'm looking for is actually, when I was looking at this earlier, I was able to find and spot the solar panels and web camera. Oh, nope, that's not it. There, right there. All right, let me zoom this in for you guys. In case you're wondering, that's probably that B1 camera right there on the edge. Profile, I don't think I can make it any bigger. Yeah, with a set of solar panels down here, and the antennas to transmit things back, so gives you some idea of scale there, right? Because that's about, you know, that's on a tripod. It's probably about the height of a person, more or less. Maybe that'd be like shoulder height or chest height, something like that. So with that, if I zoom it back out on the edge there, it gives you some idea of the size of that crater. Okay, there's a couple other pictures as well released from that flight. This one is a cool one. Obviously, the main lava lake area is in here, and we've been talking about that all day already. So that is why I keep focusing on what else is in the picture, right? You see all these nice layers of lava flows exposed in the crater wall in the background there. In the foreground, you see this is a November of '82 lava flow right through here. That it's kind of like a little small little cliff here. So the lava filled this area and off the image to the bottom as well, but it came against that little cliff and kind of that was the edge of it right there, right? Behind that, let's see, maybe I should zoom this in for you guys as well. There's a 82 flow. There's that edge of it, and then this browner stuff in the background. That's that Kīlauea ash from that explosive era of Kilauea. You can see here. This is the road, end of the chain of craters road, crater rim drive, I should say. Right there, where it gets truncated. There's a piece of it right there. There's a lot of ash covering it. Right in here, this is probably looking downhill. It's hard to tell exactly, right? But you see crack, 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 crack all across the road. All the way down. All the way here too, all those cracks. And if you look in the middle of this Kīlauea field, where is it? Down in here, you start to see all these hummocks, right? All these bumps on the ground. And this is something we've discussed in the past. This is the area that dates back to World War II, when the floor of the caldera was bulldozed to make it bumpy, so it would be hard to land planes there. I don't know. The Japanese were really going to land planes there, but go ahead, Dane.
I mean, the generals were so in terror of what the Japanese were capable of, just because the fog of war was so immense back then. I remember reading about one general. What his biggest concern was plague fleas would be released on the Big Island, and cause all kinds of issues, because that was happening in mainland China. So they were all kinds of paranoid. That's a whole history. We should probably I could probably do an episode on that alone.
Yeah, we'll have to come back to that at some point. Yeah, but that's cool to see that in this picture here. I keep doing that. All right. So what else can we see here? If I can keep it zoomed in, I'll pan it back to the other side here, and if we keep going across, so there's the lava lake pit, and then here is the other side of that crater rim drive right over here. That's collapsed in, and can't. There's a piece. This is a piece that's down here on this block that's detached. And if I keep panning across, further over, then over there's the other edge of crater rim drive as well, with some cracks through it as well. And it's not quite in the picture, but further over this way, there's more cracks and little and ledges. And it's little compared to the big one that drops down into the main pit here, but difficult to navigate as well, according to what the geologists have shared with us. So there's that wider view. That's a cool one. One more picture here from that closer to ground level. As we talked about, look at the camera there. You can get a cool view. This is not too dissimilar from that video I showed you guys from the Kīlauea overlook. Lava lake, pit. You really can see these spatter zone ramparts on the edge of the lake here more clearly in profile. And you can clearly see that west vent stuff, complex features in the background as well too. There's that main island. There's that little hornito-like feature spatter cone that keeps fuming and glowing just east of the island. And those other two cones that are much larger on a main crater floor. And then here in the foreground, cool to see a lot of grass right there, right? So I'll zoom back out. This whole area in the foreground is actually green, and that could be a combination of things. It looks like the lava might be a little bit older. It might be one part of it as well. There could be steam in the area that could allow the grasses to grow as a water source. Steam that's not acidic or too sulfurous in some way. And then the last thing might be that there could be more ash on here, and it could not drain as easily, and then you can have more pooling of water during all these rainstorms, that kind of thing. So yeah, that's that last view here, and we're getting too close to our midpoint break here, but we also have images of a gravity survey that occurred last week, 1 week ago on Thursday. So here they are down on the crater floor once again. Right, you can see instrumentation, permanent instrumentation here, and then they've also brought other stuff like GPS there, and it's a GPS here, and there's a gravimeter that they're setting up in this portable survey here, right? More examples of that. Running a GPS. There's Dr. Mike Poland. See the caldera wall there, the forested caldera wall. This is kind of in the, what is that, the southeast part of that caldera, kind of not that far from Byron's Ledge, Kīlauea area right there. And once again, GPS. Right, the GPS is used to help correct for uplifts or subsidence when estimating the change of mass of the gravity measurements here. So cool to see that that's happening again. I went and dug back a little bit. I found the last time I could easily find, and not to say it was the last time it's happened, but back to September 23rd, 2020. So not quite 2 years ago, but about 2 years ago, you see similar kind of survey happening here. GPS antenna being carried there. There's a panoramic. This image is not too clear on here, so I wanted to clean it up because this is a cool one. This is actually, it looks like it might be close to the area we're just looking at. Before I look at the instrument itself, there's more of that grass, those sedges all around. You can see some steam in the area. You can see what looks like puddles, like it has just been raining. Right? So it looks like water is actually collecting in the area here, so I added a little bit of other stuff in here too. But I really wanted to focus in on this gravimeter. This is what they're carrying around, and they're leveling it on these 3 feet here, centering it exactly over this benchmark, and then they let it sit there and collect their data. Right? That's the portable gravimeter that's been deployed. And you can see here, yeah, note taking, other stuff like that going on here. Yeah. This is also a continuous gravimeter station right here, right? That's noted here. But we have heard from previous volcano watches that most of those continuous instruments were lost in 2018, and they're trying to replace them all. And in the meantime, they do continuous surveys to kind of augment the whole process. And so there may be more continuous instruments up there now, but this process with the portable instruments is important too. I mean, that's what's been happening for the longest. And see, that's different from this other one we described a few weeks ago as well. Pardon me. This is an absolute quantum gravimeter. That's more of a permanent fixture at the observatory. Right, this is Volcano Watch. Goes back to March 17th of this year. And so different, just to show you guys all different uses of gravity here. And with that, we will say our thank yous. Dayton?
Right. Yeah, so do want to thank everybody that turned out today. We rely on viewers like you showing up and helping share this content, getting it out there a little bit more. So those likes, shares, subscribes, I know you hear it too much, but they really do help the channel grow. We did have a couple super chats come through. Want to acknowledge those. First one was from Chris, who says, thank you for sharing your knowledge and stories. Always appreciative of your updates. Thank you, Chris, for that $20 super chat. Jennifer has a $1.49 super chat with a black cat. Appreciate that. And Tim has a $50 super chat that says, mahalo for the weekly status reports and the retrospectives on 2018. And appreciate all that support, guys. We also do take donations on hawaiitracker.com, hawaiitracker.com/support. Phil, we do have a little bit of camera issue going. There we go. All right. And we do have a longtime supporter that we want to acknowledge as well, Cleo's Bar and Grill. They have 2 locations, one in Pāhala, one in Orchid Land. They have indoor, outdoor dining, takeout options, all that fun jazz. They do traditional dishes, but with a little local twist. Definitely check them out. Always good for locals, or if you're visiting, we recommend them, and we appreciate their support. All right. I think we can get into some questions. Did send you some photos that I just found from Maxar Technologies that posted some stat stuff from yesterday. But Richard asks, is there a known temperature range for where magma releases the most gas, or is a simple rule for it?
That's a good question. I don't really know the answer to that. The thing that I think matters is that the constraining pressure, which relates most directly to the depth, right? So really, it's about like how far below the ground is it, to the confining pressure that exists on it, that will force it to be dissolved or to bubble out, right? And that's typically why, as it comes to shallower levels, depending on which gas it is and its solubility and all of that, like that's when they're released. So they're more released like at certain characteristic depths, more so than temperatures, if that makes sense, right? With SO2 being shallower and CO2 being much deeper.
Yeah. In general, wouldn't the higher temperature, though, be less viscous and easier for it to escape the gas? Or does that not even matter, really? Well,
so, I mean, it's kind of connected, right? So as far as like viscosity, right? How fluid the lava is, right? If the lava has more gas, then it's more fluid. If it's hotter, then it's also more fluid.
Right.
And typically, when it's hotter, it also has more gas.
Right.
Yeah. So, but they're kind of two separate things there.
Right. Okay. I think that answers that question. Jari asks, if this flow continues for many more months, do you think there is it could form a pit like there was prior to 2018? So like that open conduit that we saw.
Yeah, I mean, that's an interesting question. Who knows, really, right? I mean, that's the real answer. Wait and see. As far as like how we feel about it, it is interesting that we still have that kind of persistent lake that stayed open that entire time, despite as much. I would guess that a huge amount of the volume is coming out through those ooze upflows, right? Really, and what we see peaking up in that active lake is just like a small fraction of it. It's kind of just like a sideshow in some ways, like a remnant, a relic in some ways, right? So I don't know, because I think it's totally possible that persistent lake could shut off, and that whole crust could still keep rising upwards, and we could have just ooze outs, for example. So I'm not sure, and at some point you can't sustain that, as it kind of gets wider and wider and wider, it might refocus once again, depending on the dynamics of it all. But really, there's a huge amount of lava underneath that crust that's basically changed the game there, right? So it's different in a sense where we don't have like one straight shaft down that's solid on all sides and we have liquid all the way down. It's kind of, we have a big bowl and it's all gooey on the inside and there's a big cap on the thing, and so it's a little bit different. I don't know.
It kind of goes into the next question from Victoria, who's asking about all that lava sitting there under that crust that you just described. And we've compared it to Kilauea Ikik as an analog for how long it would take the lava to cool. But is it even likely to cool where this, being in the center of Halemaumau, the hot zone?
Well, yeah, I mean, it's cooling from the top down, where the heat can escape from the upper crust. It can escape into the walls and down as well, but not nearly as fast as it can escape up and away, where the atmosphere can blow it away, right? So even with Kilauea, you know, we're seeing like, okay, you know, it might maybe cool in an order of tens of feet or whatever, but that's not surprising. We've seen that the persistent lava lake rise and fall by tens of feet, right? So we know the crust is at least tens of feet, right? The crust could be up to possibly 100 feet thick, something like that, right? I mean, just guessing, right? You know, minimum based on the lava level fluctuations in there.
Right.
So yeah, I mean, Kilauea gives us the overall trend, but Kilauea's trend of cooling kind of starts once the lava stops going into it.
Right.
And we haven't got there yet. I mean, we did get there in May last year.
And I'm not sure it won't be interrupted, or I'm pretty sure it won't. It will be interrupted, that cooling process. You're not going to have that kind of period of time without new lava coming in, or pressure, or gas, or heat, or, you know, it gets messy. Just
like last year, right? Like 1 year ago, the eruption was winding down. It actually did kind of stop all the way, and it went 4 months, just long enough to like screw with the terminology of it being a new eruption, old eruption, right? And then started going again. And yeah, that could be it. I mean, yeah.
All right. Well, the next question, we will use this as a transition into the next segment, where we're going to be talking a little bit about Pāhala earthquakes. And I kind of want to preempt this one because I know it's going to get asked. But Richard asks, is the Pāhala earthquake cluster the zone? Is that the hotspot, the Hawaiian hotspot?
It's associated with a Hawaiian hotspot there, yeah, for sure.
But that's not it specifically.
We don't exactly know, I suppose, is the real answer, right? It's kind of near there, right? It's an area that, as a Volcano Watch we'll discuss a little later, describes. It's an area that's equidistant from all three most active volcanoes right now, right? That being Kilauea, Maunaloa, and the
volcano formerly known as
yeah, I thought I had it, but it just escaped my mind.
It's going to take me a little while to get it
that quiz
on demand.
It's on, it's on here somewhere. Yeah, but so yeah, that's kind of the quick answer there. And maybe before I jump into that, I'll just you mentioned this Maxar Technologies tweet. Here is a tweet from Maxar Technologies at Maxar. Color infrared fast color imagery of worldview satellite from May 11th, 2022. And so there, I'll blow it up a little bit so you guys can see. There's satellite view of the lava lake, wider angle, and then zoomed in. You can see it seems like it was during a time when the lava level was a little bit lower. So you can see this rapids and a whirlpool down here at the bottom of the pit. So pretty cool.
Also surprisingly clear for the past few days.
Yeah, it was. Yeah, they must have got it just right. All right, so yeah, that's that last little bit of question for that. So let me transition here to talk about earthquakes. All right, so let's talk about recent earthquakes. First, here on Kilauea, over the last year. We saw beginning of the eruption sequence right in there. We saw a deep underneath the caldera sequence, and we've seen other Pāhala sequences in between too. But recently, really not much to speak of. It's been pretty flat, nothing really to discuss there. Zooming into the last month, you can see here one of these Pāhala. Actually, this is not a Pāhala zone because actually Pāhala is on this map. Pāhala comes in at the corner of this map right through here, so anything that happens in this corner of the map does come in here to this Pāhala zone, right? So the Pāhala earthquake, there were some bigger ones. There have been some 4-pointers in there, but otherwise everything's been pretty quiet, low background levels, nothing really to speak of there. For the last week, really quiet, except in Pāhala. South flank is still active. There's this purple deep earthquake right in here. Zoom in for you guys to see. That's deep. So let's go to the cross section. We have depth, and we have longitude, so this is just straight from the map down. All these Pāhala earthquakes plot straight down. Under here, all the blue ones. You can see there's a disconnect, there's a gap, and all the shallow ones up here. And then here's that deep one closer to Kilauea. It's easier if we scroll down to the last week, or I'm sorry, the last month. Let's put the whole last month on here. There's a lot more Pāhala earthquakes, a lot more South Flank earthquakes, but also more of these deeper purple and deep blue earthquakes around Kilauea. Right? So, looking at the cross section, and here you can see some of these deeper earthquakes here. There's one off to the side here, and then some of these other ones coming shallowing upwards here. And Pāhala is this cluster right over here. Right, and lots of shallow earthquakes have been occurring over top of it as well. But there is no connection of magma moving from bottom to the top. It's kind of like bulging. It's almost like a subterranean, really deep boil kind of thing that's just kind of pushing all the rocks above it, right? All this 20 miles of rock above it, bending it upwards. And the very top part of it, where it's the coldest, the most brittle, is where it's showing these little fractures, right? And so it's kind of a growing question as this swarm lasts longer and longer and longer, exactly what kind of connection will develop through here, if any at all, or if this might be something that connects elsewhere to the volcanic systems. And so to shed a little bit of light on that, I wanted to show you guys some of these other views, right? So here's a view slicing Kilauea into layers, this upper 5 kilometers, the next 10, the next 5, and then this is the bottom 40 down here. Right? And so the point being that we're used to seeing all this shallow stuff. This is the upper one. This is essentially the rift zones right through there, right? Then we see South Flank here, and then further down as well. There's a gap where you really only see stuff around the conduit, and then kind of between Maunaloa and Kilauea. And in that lowest most panel, right, there's actually a whole cluster of earthquakes that spread out kind of to the southwest, right, that seem to be fairly consistent there, right? That's kind of one view of it. And there's other stuff as well, but we'll keep moving for now. Perhaps you've seen this graphic, which shows the upper magma system, magma chamber network perhaps, rift zone southwest, southeast. Here's our scale, 0 kilometers, 5 kilometers underground, 10, 20, 30, 40. And then deep down in here, the deep seismic zone, somewhere below that basal south flank fault, and near that magma source as well. Right? So this is very abstract, really, when you think of it. As, you know, it's hard to see things that are that far down. So I pulled out this paper from Wright and Klein USGS 2006, and we have here essentially. Let's go through this kind of one panel at a time, right? There was an earthquake. I want to say it was a 5.2, maybe it was a 5-pointer that occurred down here in 1994, February 1st, and had a whole bunch of aftershocks. And that was a really unique earthquake in the sense that it seemed to light up the area of magma pathway, which they've kind of drawn on an envelope as kind of like this, right? There's deep earthquakes coming up and over here, right? And this is really far down. This is 20K at the shallowest, 30, 40, and you can see that if we get down below 35 to 40, it kind of narrows into this kind of more vertical with less distribution, right? And this is all offshore. Here's caldera, Hawaii, onshore, and offshore, right? So this earthquake was just offshore on the map, and you can see there is that cluster on a map zone of that whole transport system right through there. Right, so just for comparison there, right, to where this earthquake is. These deep ones here, slightly to the side over here and over here, right? But some of these are fitting quite nicely in that pattern. That's not the only earthquake. There are other ones as well. So there are other clusters that occur, like this set of earthquakes here. That cluster is closer to this northern edge of that transport zone. Right, to look more like that. When it shows up on a map onshore, that's where it falls underground. And we've also had other ones that fall right over the caldera itself. And here you can see shallow earthquakes, long period earthquakes right through here. But there is that transport zone from deep, and they note a mineral difference right through here that could be a possible pathway for the magma to take advantage of, right? And that would pick the path of it from deep over here. And you see the big arrow, deep magma path towards Kilauea right through there, right? So we haven't quite got to Pāhala yet. Pāhala is still off to the side over here. But just to show, there are also, besides this southern transport route, there are times when there's earthquakes that are more directly under the summit itself. And if you look at this in the cross-section here, you can imagine it seems like there's also something that's more vertical and that comes straight up underneath it as well, right? So you have like pathway 1 straight up, you have pathway 2 that comes up and possibly comes over and straight up, right? And I say all this because we're going to get to this cross-section that we've shown before. Up here is the data, all the earthquakes, and you can see that earthquakes line up. They form these lineations right through there, right? And you can see it's probably more easily in a schematic right over here, where there are deep tremor earthquakes occurring further down. There's a mantle fault zone, right? It's speculated that a possible transport path does exist from this deep tremor zone under Pāhala to the northeast, and then that could join that Kilauea system. This is Kilauea summit caldera zone right through here. So it's not exactly the same, right? But you're talking about possible pathways into Kilauea. There's possible the one straight below. There's possibly the one from slightly southeast. And then we're talking about possibly a third one that might come from further over and come up and in, right? Now the difference is that we discussed this being equidistant from other volcanoes. There's possibly other pathways that also go off in other directions, right? Towards Maunaloa and then towards Loihi as well. Right? Volcano formerly known as Loihi, whose name I have to practice. So that's the big picture of Pāhala there. Volcano Watch this week, using earthquakes to look under the hood at Pāhala. So let me switch us to our Volcano Watch here. USGS Weekly Volcano Watch. So it is noting that earthquakes are being felt in the area all the time, and across elsewhere on the island fairly consistently as well. Comparison from March to May of 2014 compared to 2022, big difference. It's really ramped up quite a bit, right? And so there also have been, since August 2020, larger magnitude earthquakes occurring. There have been 8 magnitudes, 4.2 to 4.6, at depths between 19 and 21 miles recorded, and have been felt all over the islands, really. So, in the end, we need more information. That's what it comes down to. So HVO in collaboration with Manoa is this summer going to be deploying a network of these seismic nodes. Here's one deployed by HVO seismologists on a down-drop block in Kilauea. Right? There are similar things that were deployed in the Lower East Rift Zone as well in 2018, but they're essentially going to deploy them across Pāhala this summer to get a better resolution and try to image in more detail what's happening in Pāhala. So we'll get an answer to this probably in the fall or later. But they're saying that they're going to be able to image down to 25 to 31 miles below sea level, all the way to the surface from this series of nodes. So they'll plan to share the results after they're processed. In the meantime, if you're in Pāhala area this summer, please watch out for the seismic nodes that are recording valuable data to help HVO shed light on the mystery of frequent earthquake activity deep below. So in the end, we don't exactly know. I wanted to show this graph from another previous USGS talk showing earthquakes per week and in the year 2012, 13, right? And really showing how these earthquakes picked up in 2014 and 15, and that was a lot. And then there was a flurry that occurred post 2018, and it took a little while, but actually in mid 2019 is when it really began to ramp up. And then really, there was like a first pulse. And that second pulse in mid-2021 has really come up quite a bit higher. So this is where we are now, is in the middle of this latest pulse. This goes back to a few months ago, so I really don't have the most current data on the right side here. But once again, comparing 2013, 2017, 2021, as far as how it looks on that map right in there. Right, so that's what we have to summarize for Pāhala. What we know so far, it's not a huge amount. We do know that magma has not come to the surface from that area straight up in the past. Maybe that could happen in a future, in a geologic future. I wouldn't say like in a human life future. Most likely, it seems like these things take a long time to develop. To the best of our knowledge, right? That rock is still moving. If we see earthquakes migrating to the surface, we'll change our tune. But until then, I see no cause for further alarm. It's just really interesting. Is it because a hotspot's putting out more magma and it's trying to feed all the volcanoes? Is it because it's going to Kilauea more? Is it trying to go other places? Who knows? Well, the imaging will tell us much more of those details. That for now can only be speculated on, right? But as far as Maunaloa is concerned, we can say that the earthquakes on Maunaloa have not really gone up with Pāhala earthquakes. They have been fairly steady background levels. There was a little bit of a ramp up, a little bit of a peak here that occurred earlier in the year, really fairly short-lived compared to what's happened in the past. And we're really back to background. Not a whole lot happening in Maunaloa right now. Cross caldera at the summit of Maunaloa. Pretty unconvincing movement, right? Maybe a slide upwards, but not very fast, if so. And really nothing to speak of for Maunaloa there. So it's one thing to mention. All this data is just reconstituting what the USGS is putting out there. So mahalo to the USGS Hawaiian Volcano Observatory. All information can be gotten on their website, and including all the daily updates here, which is where all this comes from, right? So no new stats to report today. We'll have more of those next week, more than likely. Kilauea remains at color code orange, alert level watch. Here. All right, so what I wanted to do now, Dane, is switch to remembering 2018. And what we have today is a short video. It's like 6 minutes long, maybe 7 minutes long, from IRIS Consortium, collaborating with NSF, Stanford, USGS, of the collapse of the caldera in 2018. So I thought that we could play this for you guys and watch it. And
can you turn on your screen share for me in Meet so we can get the timing right on it?
Let's see. Let's see if this
actually works.
Otherwise,
I'm worried about just being us out of sync.
Yeah. Okay. So.
Perfect.
All right. Let's see. I'm not sure which of my screens you're seeing, but
right now I'm seeing the Meet and OBS.
Okay. All right, guys.
I can work with that. Yeah. I can work off that.
Thanks for bearing with me. Okay, so let's see.
I can work with off the OBS.
All right.
How about I just pull it up myself and we'll just run it that way?
Yeah. Okay. So, all right, I want to put this on the screen for you guys, and maybe we just play it through. Unless we have a need to interrupt, we can play it through, and we can kind of sum up and look at it at the end. What do you think, Dane?
And we can talk over it a little bit too every once in a while if we want to.
All right. If I can operate that, we'll see what we can do.
All right. But yeah, I'm ready to queue up with beside you.
All right. Okay.
So yours is independent.
Here we go. Ready, set, play.
In 2018, Kilauea volcano experienced its largest caldera collapse in more than 200 years, profoundly changing the landscape. Hawaiʻi Volcanoes National Park, home of this popular visitor destination, was closed for 4.5 months due to unprecedented volcanic and seismic activity that damaged its infrastructure. Over a period of just a few months, the bottom dropped up to 500 meters with a total collapse area of 5 square kilometers. The collapse was accompanied by an outpouring of lava 40 kilometers from the summit that covered over 35 square kilometers of land, destroyed 700 homes, and displaced over 2,000 people. Scientists can often forecast when and where an eruption will occur. In 2018, there was clear warning of potential for eruption in the lower East Rift Zone. Caldera collapses are fortunately rare, as they are associated with the largest volcanic eruptions. Sensitive monitoring equipment has helped scientists understand how magma moves below the surface, how it is stored, and what triggers a caldera collapse. So, what have we learned from this episode, and how might it improve our understanding of volcano hazards? Kilauea volcano is the youngest and most active of the 5 volcanoes on the island of Hawaii. Eruptions are concentrated at the summit caldera and within 2 rift zones that radiate away from the summit. A cross-section will help us describe what happened in 2018, both at the summit caldera and within the East Rift Zone.
It's cool cutaway.
The summits of most large shield volcanoes are occupied by collapse features called calderas. Calderas are large.
Yeah. Right. It just feels like a missed opportunity to just put that the one magma diagram that we always use in that cutaway. Yeah. Yeah. Yeah, that just feels like a missed opportunity right there. It feels so natural, and then it just wasn't there. More detailed. Yeah. All right.
The summits of most large shield volcanoes are occupied by collapse features called calderas. Calderas are large, basin-shaped volcanic depressions that form when magma is withdrawn or erupted from a shallow underground magma reservoir. Calderas are observed at hundreds of volcanoes around the world. Fortunately for us, caldera-forming eruptions are rare, as they can be extremely hazardous. Hawaiian caldera collapses tend to occur during passive eruption of fluid magma at distant vents, versus the more dangerous explosive volcanoes that form calderas during catastrophic eruptions of pumice and ash. Rift zones are linear sets of cracks and fissures that can facilitate the movement of magma below the surface. The eruption that created the Pu'u'o'o cone began on January 3rd, 1983, and erupted nearly continuously for 35 years, relentlessly mantling the landscape with over 117 square kilometers of lava. During that time, magma rose from deep in the mantle, forcing magma stored in the summit reservoir down the East Rift Zone to erupt at Pu'u'o'o. On April 30th, 2018, Pu'u'o'o abruptly collapsed and shut off. Following this, earthquakes and ground deformation moved down the East Rift Zone as magma forced its way underground, ultimately erupting in the Leilani Estates subdivision. By mid-June, lava was erupting at a rate nearly 50 times the rate that it had been venting at Pu'u'o'o. We will use a highly simplified cross-section of a magma reservoir and the overlying caldera to look at the subterranean architecture of Kilauea, and to show how the massive outpouring of lava in 2018 caused the summit of the volcano to collapse. The shape of the subterranean magma reservoir is only roughly known. We idealize its shape here for simplicity. Sensitive instruments that measure motions of the ground's surface record changes in pressure within magma reservoirs. When pressure increases, the ground bulges ever so slightly upward, much as a balloon inflates. When pressure decreases, the ground surface slightly deflates. In 2018, magma flowed out of Kilauea's summit reservoirs far faster than it was replaced by fresh magma from the mantle, causing the pressure in its summit reservoir to decrease and the active lava lake in Halemaʻumaʻu to drain away. As the eruption continued in May of 2018 and the magma pressure decreased, it could no longer support the weight of the overlying crust, which is about half a mile thick and over a mile across. As the overlying crust began to break, thousands of small earthquakes occurred on the edges of the caldera block. Eventually, the stress became too great, and the caldera block dropped almost 10 feet in a matter of seconds. The small earthquakes immediately stopped. As the block dropped, it squeezed the underlying magma, increasing its pressure. This pressure pulse sent surges of magma down the rift zone, peaking about 3 hours after the collapse, 40 kilometers down rift in the Leilani Estates. As magma drained from the summit, the surge diminished, and the pressure of the magma within the summit magma reservoir began to decrease again, and the cycle repeats. Ultimately, the summit collapsed in 62 discrete events, spaced roughly a day and a half apart. The graph shows the sudden drops of the COWS GPS station, which occurred over roughly 10 seconds per drop. The cumulative effect of these collapse events was to form a new caldera, nested within Kilauea's pre-existing caldera that formed about 500 years ago, with a floor fully 500 meters below the previous bottom of Halemaʻumaʻu crater. Finally, on August 10th, the eruption stopped. Scientists are uncertain as to why it stopped so abruptly. Because Kilauea is so well studied and covered by state-of-the-art monitoring devices, we were able to take the pulse of the volcano as the caldera formed. Lessons learned during the events of 2018 will be incredibly helpful in guiding response to future volcanic eruptions around the world.
Good video. My main thing would just be the terminology, like the idea that created a new caldera. When we talk about it, we usually talk about it as a partial caldera collapse, not a new caldera is formed within the old caldera, as if like a nested structure.
Right. So sorry, you guys, I was muted a little earlier. Yeah, I was trying to keep it quiet for you guys there, but the point is that I was making is that this is very simplified, of course, compared to the diagram, and we showed you guys here. This is the USGS diagram from professional paper that shows in more detail here a larger south caldera, a shallower Halemaʻumaʻu reservoir, or I'm sorry, a south caldera reservoir, I should call it, right? And then a Halemaʻumaʻu reservoir that's shallower, and then a connection to the rift zone that in this case is drawn through a Kīlauea reservoir through the south caldera. Now this connection, there may be connection from Halemaʻumaʻu here also as well. This whole is really best put as a question mark, this whole area right there. Right, so this is where they've really simplified it and drawn it as just like one big thing and one arm going outwards, right? That's their simplification there as part one. And as Dane says, we really only formed, if I can get the video back here. Where is their cut? Right here. This 2018 collapse outline in blue, right? This is their collapse area. But it really is, like Dane says, only a partial caldera collapse, because the whole caldera that exists now goes off that way, over here, and over here, like that, right? So there's a whole bunch of it that didn't get impacted all through here.
They do one thing that they, in that, the overly simplified representation, the cross-section, it seems like there's a lot they don't get, but there's one thing they do get, and that seems like the amount of the summit or of the reservoir that drained in 2018. They don't say it, only a small percentage actually drained of the total amount up there, but they do show it.
Right.
Pretty accurately. and that part, and even the offset nature of it, it's like, okay, that's legit.
Right. Yeah, so that's cool, and the schematic of the surge coming through is interesting as well, right? The thing that I hadn't seen before is this one right here, right? This animation of the cross section
in 62 discrete events.
I'm muted here so you can see it, but yeah, you can see all these different frames of different collapse. I thought were really cool right here to see. They've drawn in here the schematic fault lines that are separating these different blocks going down. So that's pretty cool to see right there.
Yeah, they took their time on that stick figure drawing.
Yeah, I mean, you have to make each frame independently, right? And then animate them all, of course. So yeah, a lot of work there.
Was the cows station, that was the one that fell into the thing, or was that a different one? I can't remember right now. One of them fell into the abyss. One of the monitors.
Yeah, that was a different one, right? The caldera south. I think that one is still there.
Oh, yeah, that one.
There was another one, North Pit, maybe.
I can look it up.
North Pit, I want to say.
I'll have to check real quick.
Yeah. In any case, there was one I fell in, but it was more over here-ish, right, where the pit actually is now. So yeah, pretty cool. Yeah, this was pretty cool, this animation of putting the Empire State all the way in that pit, obviously, right? So here it goes. Stick
looks
it in
like
the
it's
pit.
the VO46.
Oh, okay. And compared to that Empire State, we've discussed now that we're kind of up at this observation platform level right in here. And so we've buried almost that entire building since the collapse. December 2020, when lava started coming into it here. So yeah, that's all my thoughts. I thought they did a pretty good job. Otherwise, simplifying it is very instructive. It's probably useful to hear someone else talking about that besides us, of course, right? In case you guys haven't seen it before, let's see if I can get that sequence of the collapses going on here. Right there it is. You can see this crack opening up during the earthquakes, and then all the dust falling down from the crater walls.
That one, you really need the sound in it. That's one of the few clips from USGS during the eruption where the sound was vital, because you just hear the rock wall slamming back against itself.
Yeah,
everything in there. It's pretty wild.
Break. Thousands of small
For anybody
earthquakes.
that hasn't seen that clip before.
Yeah, they're talking about. We'll have to pull it out and play it with a sound sometime, and not talk over it. But yeah, that's just a little window into what the collapses were like. Of course, this doesn't do it all justice, but I didn't want to go too deep into it. Of course, it was 3 months,
Right.
3 months of collapses for the volcano residents. Were not affected by lava really, but it was earthquakes every day. People couldn't sleep. Got off easy in the end, really, when it comes down to it, compared to everyone down in Lower Puna, right? But it was certainly disruptive for the volcano residents as well. So worth mentioning at some point, and this is the point right here.
Yeah, good little video for them to put out, right on the anniversary or right before it.
Yeah, for sure. Yeah. While we're on 2018, I had a couple other things to talk about real quick. This is one I know you saw on Twitter, Dane. This is a tweet from Dr. Fabian Wadsworth here at Wadsworth Fabian. They published a new article that's based on eruptions in La Palma and in Iceland, right? This is actually noting the high volume of amazing amateur and semi-professional videography of recent eruptions that may be an interesting and important resource for volcano science, as well as being artful and wonderful in its own right. So they're talking about using drones. People who are regular citizens using drones and then sharing the data with scientists who could learn, process during COVID when it couldn't travel as well, right? Especially for the Iceland one. Not quite as much activity happening in La Palma because, like Hawaii, there was a lot of impact on people and infrastructure. But there was a lot more that occurred in La Palma than occurred in Hawaii, because in La Palma they still had media flying drones, and the media would share the drone footage with agencies, and so it wasn't like a free for all, so to speak. It was regulated. But there was more than just the scientists doing it, right? So
Right.
look for this
And
on.
we've been,
Go ahead.
yeah, that's great. It's great that they actually, have something in nature that, some we can cite, because we've been talking about this for years, since 2018, that the necessity of those drones and the role that they play in the disaster scenario. And, the problem is instead of having some, a way to work around right now, the county is just flat out banned. In 2018, they're just flat out banned. No drones allowed for civilians. Helco could fly and things like that. So it's starting to move in a direction that makes more use of the technology.
Well, so that was the main difference, really, that I wanted to point out from 2018 in Hawaii to these other eruptions, was the fact that there was a ban, right? And the justification given was that they were flying helicopters and they had to make sure that there wasn't interference. That's totally valid. But were they not flying helicopters on La Palma, or did it just actually organize themselves better to manage to do both things alternatively, one not getting in the way of the other, right? Which is what I would like to believe is possible to happen in Hawaii, right? Rather than just ban it.
There was just no will to try and make it work in 2018.
They were so behind on everything, right? Yeah. In hindsight, that was, of course, not going to be a priority, right? Totally. But what the point is this is popped up other places in the world again, and it's being pointed out as being useful, right, by the scientists themselves, right? And I don't want to put out a whole paper. You can follow the link to read it for free online here, right? But there's a couple of things I wanted to talk about, right, that I think are worth pulling out of here. One is he discusses this volcanologist paradox, right? And this is the tension that arises because eruptions are scientifically fascinating while also being events that have a real human cost. Recent experience has suggested that one key to reducing the tension between awe and hazard acknowledgement is a collective sense of trust and community involvement, an ad hoc collaboration across professional teams and local people in the field. For safety and science equally, more eyes are better than fewer, and a coordinated constellation of drones serving both purposes has merit. Yet the idea is not without budgetary and feasibility challenges.
Oh no! Okay, we've already solved those ones. Yeah, budgetary issues. Like we have a solution to make money for the county.
Yeah,
not lose money, make money. It'll be profitable.
Yeah, if you come at this from not the scientist side, but from the county side, it's different, right? Obviously, he's speaking from the scientist side.
Yeah.
One solution could involve drawing upon citizen scientists from the regional community, volcano tourists, and videographers that could form auxiliary teams and deploy their experience to the task of observation. When conducted for both civil and scientific purposes, this would represent a whole society task to what is, especially in the case of Cumbre Vieja, a whole society impacting eruption. That is exactly what happened here. And in fact, that drone effort did occur, but it had to occur in secret because of the ban. The footage was not released publicly. It was shared with the local community and the leaders on the ground so people could know what was going on, but it could never be put out in public officially because of the ban, because of the lack of preparation and organization of the government. So I'm putting this out here now because, as we're fresh with 2018, and next time this happens, there is no excuse to do the same thing again. No excuse.
Some of the craziest footage I saw in 2018 still hasn't been released yet.
Yeah, because
and it probably won't be released, type stuff, because it's that gnarly. And it's just the guy that filmed it wasn't supposed to be filming it, type of thing, and now you don't get to see it. And it's like some of that footage is mind-blowing though.
Yeah. Social media has acted as a dynamic meeting point for volcano enthusiasts, photographers, videographers, and volcanologists. Platforms such as Twitter, YouTube, Facebook, and Instagram are a primary point of content exposure and sharing, and therefore the place where collaborations we are advocating may be born. Right, so they note COVID.
Oh, Robin George Andrews, yeah, I know that guy. Yeah, that guy's a good guy.
They note COVID. We conclude. So for volcanologists who are not able to visit these eruption sites for logistical reasons or due to COVID, the opportunity via social media to engage with, share, and ponder the eruptive processes has been spectacular and has prompted vivid scientific discussion worldwide. We conclude this is in part due to the incredible work by content creators in documenting this eruption in unprecedented detail and resolution. Right, so this is just, I I probably should leave it at that, because this is something that we could have done better, right? If you ask someone today, they'll be like, well, but they led the guy to safety with a drone through the forest the one time, and
even that was a shit show.
That was a little bit, didn't quite go down. We having spoken to the person himself. They say that
did not go down as cleanly as it was.
It's not exactly how it was portrayed, but okay, there was a drone involved, and great. I'm glad that they tried that, and that's fantastic. But that was one instance in 3 months, right? So, and there is a lot more out there, and so if there were to be, a call for it, right? There certainly could be more of that footage shared with the scientific community, and science could learn from that as well, right? But as it is now, you're kind of forced to wait for this whole, I don't know, other aspect of it, right, to sort itself out. So,
yeah,
but
it can be done, and it wouldn't even be that bad. And hell, we talking to guys at FAA, and they were even talking about like how it was possible and it wouldn't even be that bad. 200-foot ceiling for the drones type was their one solution. You can operate drones up to 200 feet. 200 to 400 feet is emergency operation choppers, and then above that is 3,000 foot or temporary flight restrictions for civilians.
There are ways to license this, right? The Civil Air Patrol and other places already has drone pilots that operate as civilian assistants during emergency situations. This already exists. Just bring it here. Just wake up, people. All right, so I'll get off my box right here. It's just worth noting that this is besides Dr. Fabian. Let's see, somewhere on here, he actually shows all the authors. Authors from here we go. A whole bunch of people that worked in all these eruptions are all who's involved in this article, crowdsourcing observations of volcanic eruptions.
Oh.
Right,
Virginia's
so
in there.
including Virginia, So this is I've said enough.
Yep, definitely worth checking out.
Yeah, a couple final things here. One is Kilauea Eruption Recovery has this website. They only have 36 subscribers. Go help those guys out. Someone go sign up for their videos, please, if you interested. Like they have, for example, commemoration of 2018. They have the updates like Revitalize Puna recaps, as far as updates on Pohuiki Road, like all those other kind of meetings. So check them out. Let's try to get these guys a little bump if we can here, right? These guys, work with us all the time.
36 subscribers, and Phil and I are 2 of them.
Come on, people. Yeah, help them out, right? I should be able to refresh us and see like 50 right now, right? I won't put you guys to the test. But Kilauea Eruption Recovery. Good place to go get more information for 2018. And one last thing, posted on our channel on YouTube earlier this week, and we also streamed on Facebook earlier, is this Memories and Reflections from Punamakai in 2018 eruption. So this is a little talk story Dan and I did with other community members. So it's over an hour long. I'm not going to play it all here, but we did spend a lot of time. If you guys want to move from our live update now to that and listen to that, it's not at all a science. We're just talking about our reflections and memories and feelings,
right.
As far as that goes.
It's more of the community too. It's good to have the more local perspective on things. Because we always talk I always talk about like how the Hawaiians from Kalapana really pulled weight, especially in the beginning of the eruption when nobody knew what was happening.
Right.
And to have the Hawaiians from Kalapana talk about it, it's like they don't get to talk about. I don't see them talk about it, as much as we've talked about the eruption, because we talk about it, every other week or something.
It's just their own background, really, right? I mean.
Yeah.
But it doesn't mean that they're not thinking about it all the time, right? If you go, the speaker on the Kilauea Eruption Recovery video, talks about living in Kalapana and going through other evacuations, losing your house in Kalapana. Something Ikaika has talked about as well. We'll come back to all of that, like stories of the hub and stories of Puna in the future. But I don't want to jump into it too much right now because it's obviously we're still a little triggered. If you listen to my drone rant over there, you can tell, right?
Yeah. All right. Well, I think that does it for this week. We will be back next week, same time, 5 p.m. Hawaii Standard Time on Thursdays. Unless something goes down, then we will go live. We don't really expect anything to go down since everything's so quiet right now. But if it does, we will go live. And I think that's good for me, Phil.
There was one question that got brought up last week about the tremor down in the Lower East Rift. Yeah, we've still been looking at that. There was just that one episode of tremor on the Lower East Rift. I actually didn't even say Lower East Rift, just said on the East Rift somewhere. And it hasn't happened since. It's something the USGS has been noting in their updates every day that there is no decline, no more tremor happening there. So it's not unusual for there to be little movements here and there. But all that matters in the Lower East Rift is that everything is still quiet down there. There's nothing to worry about. One little movement is normal, and it's just something that kind of like all eyes are on it now. So it's something that will get noted. Whereas I don't know how many times that kind of thing happened in the past, and I'd be like, something's going on. No one would care or notice, or nothing changed, and no impact visible, and that was into that. So yeah, that kind of thing happens. It's just I suppose more noticeable now because we're post 2018 and we are all a little traumatized still. But bottom line, nothing to worry about down there. So I just want to restate that one more time. Yeah. So. I see someone here saying if we start a GoFundMe to get a drone and audio video gear. We do have some of that, right? But all our gear is all getting pretty old by this point in time, and rain soaked and rusted and corroded and VOG impacted. And man, anything we use in 2018 is like lost a lot of life just from the elements of having you feel free to donate to us through hawaiitracker.com. We do if we eventually can get enough fundraising, we'll replace our gear as well too. Besides trying to not volunteer all of our time here, which is what we mostly for the most part have done ever since the end of our grant a few months ago.
Right. All right.
All right. Thanks once again, everyone. Until next week, from hawaiitracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.